Imagine rain that has been falling for millions of years. Scientists call it ring rain. Every second, up to 45 tons of ice particles break away from Saturn's rings and fall into its atmosphere. This is not a hypothesis. This is data obtained by the Cassini probe in the final hours of its mission, and it means one thing. Saturn's rings are not eternal. They are dying right now. When you look at Saturn through a telescope, you see a symbol. It is the most recognizable object in the solar system after our own sun. But what seems eternal is in fact only a moment in the scale of space. In 100 million years, the rings will disappear completely, and that is an optimistic forecast. October 15th, 1997, Cape Canaveral, Florida. At 4:43 a.m. Eastern Time, the Titan launch vehicle lifts off from the launch pad. On board is the Cassini-Huygens Interplanetary Station, a joint project of NASA, the European Space Agency and the Italian Space Agency. The mission cost $3.2 billion. Its destination is Saturn. Ahead lies a 7-year journey through 3.5 billion kilometers of emptiness. None of the scientists who launched this spacecraft could have imagined that Cassini would deliver the verdict on Saturn's rings, a verdict that cannot be appealed. After gravitational maneuvers near Venus, Earth and Jupiter, Cassini enters Saturn's orbit. A 13-year odyssey begins, the most detailed study of the giant planet in human history. During this time, the spacecraft will make 294 revolutions around Saturn, transmit 453,000 photographs to Earth, and collect data that will revolutionize our understanding of this world. But the main discovery awaited scientists at the very end. When the fuel was almost gone and the mission was coming to an end, the team made a decision that seemed crazy: to send Cassini where no Earth spacecraft had ever been before, into the gap between the planet and its rings, an area only 2,400 kilometers wide, a narrow corridor between the gravitational well of the gas giant and trillions of ice fragments hurtling at a speed of 70,000 kilometers per hour. On the 22nd of April 2017, the grand finale began. 22 suicidal dives between Saturn and its rings. With each turn, Cassini descended lower and lower, closer and closer to the planet's clouds. The instruments were working at their limits, transmitting data that scientists will analyze for decades to come. And it was then, in those last 5 months of the spacecraft's life, that Cassini's mass spectrometer recorded something that changed everything. It was raining on Saturn, not rain in the usual sense, rain from its own rings. To understand the scale of what is happening, you first need to understand what Saturn's rings are. The diameter of the ring system is 270,000 kilometers. That is more than the distance from Earth to the Moon. If you could drive across the rings in a car at a speed of 100 kilometers per hour, the journey would take more than 112 days of continuous travel. But despite this enormous width, the rings are only 10 to 100 meters thick on average. Think about it. If Saturn's rings were the size of a football field, they would be 10,000 times thinner than a razor blade. It is not a voluminous structure, it is a film. A thin, icy membrane stretched around the planet. The mass of all the rings is approximately 15.4 multiplied by 10 to the 19th power kilograms. It sounds impressive, but it's only 41 hundredths of the mass of Mimas, one of Saturn's small moons. Or, to put it in Earth terms, about 2/3 of the mass of the entire Antarctic ice sheet. All this beauty, which we have been admiring for 400 years since Galileo's discovery, weighs less than the ice on one continent of our planet. And this ice melts, not from heat, from gravity. Cassini data revealed 2 destruction mechanisms operating simultaneously. The first is ring rain. Ultraviolet radiation from the sun and plasma clouds from micrometeorite impacts electrically charge the ice particles in the rings. The charged particles begin to sense Saturn's magnetic field. The lines of force of this field bend towards the planet and the particles follow them, along invisible magnetic rails, straight into the upper layers of the atmosphere at mid-latitudes. The speed of this process is between 432 and 2,870 kilograms of water per second. That's enough to fill an Olympic swimming pool in half an hour, but that is only part of the sentence. The second mechanism proved to be much more destructive. During the grand finale, Cassini's mass spectrometer discovered that a huge amount of material was falling directly into Saturn's equatorial region from the inner D-ring. without the mediation of a magnetic field. It simply fell under the influence of gravity. The speed of this equatorial downpour is between 4,800 and 45,000 kilograms per second. That is dozens of times faster than the ring rain. James O'Donoghue from the Goddard Space Flight Center has done the maths. Ring rain alone will destroy the ring system in 300 million years. But when equatorial fall is taken into account, the time frame is reduced. Saturn's rings have less than 100 million years left. The inner rings C and D may disappear much sooner, in a few million years or even tens of thousands. 100 million years. That sounds like an eternity to humans. But for the solar system, which is 4.5 billion years old, it is but a heartbeat. This means that Saturn's rings have already travelled most of their journey. We have caught them in the last quarter of their life, perhaps in the last tenth. And here begins the second part of the riddle. If the rings die so quickly, then they cannot be ancient. This implies that at one time, they did not exist. In 2022, a group of scientists from the Massachusetts Institute of Technology, led by Jack Wisdom, published a study that proposed an answer to the question of the origin of the rings. And that answer turned out to be a murder mystery. About 160 million years ago, at a time when dinosaurs roamed the Earth, Saturn had one more moon. Scientists named it Chrysalis, which means cocoon in Greek. The name was not chosen at random. Just as a caterpillar turns into a butterfly, this moon turned into rings. Chrysalis was about the size of Iapetus, Saturn's third largest moon. Its diameter was approximately 1,470 kilometers. It was composed mainly of water ice. For billions of years, it had been quietly orbiting Saturn, somewhere between the orbits of Titan and Iapetus. There were no signs of impending disaster, but the universe is a system of interconnections, and one of these connections turned out to be deadly. Titan, Saturn's largest moon, is slowly moving away from its planet. The migration speed is 11 centimeters per year. That's not much. But over billions of years, Titan has shifted enough to enter into orbital resonance with Chrysalis, 3-to-1. For every 3 revolutions of Chrysalis around Saturn, Titan made 1 revolution. Gravitational jerks accumulated. With each cycle, Chrysalis's orbit became more and more elongated, more and more eccentric. Computer modelling showed what happened next. Out of 390 simulations, in 17 cases, Chrysalis came too close to Saturn. It didn't crash. It didn't collide with another moon. It just came too close. There is an invisible boundary around every massive planet, the Roche limit. This is the distance beyond which the planet's tidal forces exceed the gravitational force holding the satellite together. For Saturn, this limit is about 147,000 kilometers from the center of the planet. Chrysalis crossed that line. Imagine, an icy body with a diameter of almost 1,500 kilometers is approaching a gas giant. The side facing Saturn experiences a stronger gravitational pull than the opposite side. The difference between these forces, the tidal force, begins to stretch the moon, slowly at first, then unstoppably. The ice cracks. Cracks spread across the entire surface. Pieces break off and fly off in their own orbits. A body that has existed for billions of years is torn apart in a matter of hours. 99% of Chrysalis's mass is absorbed by Saturn. The giant devours its moon. But 1%, about 1% of the icy debris remains in orbit. These fragments collide with each other. They break apart. They are crushed. Over the next 100,000 years, the chaotic cloud of debris gradually flattens out, flattened by Saturn's rotation, and turns into what we now call rings. This is what Saturn's rings are. Not an ancient structure left over from the planet's birth, not an eternal symbol of cosmic harmony. They are remnants, a graveyard of a moon torn apart by gravity 160 million years ago. We look at the shining disk around Saturn and see a corpse, and this corpse continues to decay. Slowly, inexorably, irreversibly. 15th of September 2017, 4:55 AM Pacific Time. The signal from Cassini is interrupted. The spacecraft enters Saturn's atmosphere at a speed of over 123,000 kilometers per hour and burns up like a meteor. 20 years of mission, 13 years in orbit, 453,000 photographs, and 1 minute from entering the atmosphere to losing contact. The team at the Jet Propulsion Laboratory in Pasadena greeted the end of the mission with applause and tears. Cassini didn't just collect data, it rewrote the textbooks. Before Cassini, scientists believed that Saturn's rings were the same age as the planet itself, 4.5 billion years old, a relic of the era when the solar system was formed. Now we know that the rings are between 100 and 400 million years old. They're younger than the dinosaurs. They appeared when complex life already existed on Earth. Before Cassini, it was believed that the rings consisted of pure water ice, 99 9/10% frozen water. Now we know that this is not the case. The spacecraft's mass spectrometer detected methane, ammonia, carbon monoxide, molecular nitrogen, carbon dioxide, and fragments of complex organic nanoparticles in the falling material. Water accounts for only about 24% of what falls into Saturn's atmosphere. The rings turned out to be not an icy halo, but a complex chemical cocktail. Methane was the main surprise. No one predicted its presence in the rings. Before Cassini, we didn't know how deep Saturn's atmosphere rotates. Now we know. Layers of gas rotate synchronously to a depth of up to 9,000 kilometers. That is 15% of the planet's radius. 3 times deeper than Jupiter. The mass of Saturn's core is between 15 and 18 times that of Earth. But the main discovery is not the figures. The main discovery is the realization that we are living in a special era. Jupiter, Uranus, Neptune. All gas giants have rings. But these rings are dim, barely noticeable, almost invisible. Perhaps they were once as magnificent as Saturn's rings. Perhaps we are simply millions of years too late. Saturn is the last of the giants still wearing its crown, and that crown is melting away. On the 23rd of March, 2025, Saturn's rings will disappear. Not physically, but optically. The planet will turn its rings towards Earth, and the structure, tens of meters thick, will become invisible from a distance of 1 billion kilometers. This happens every 13 to 15 years. It is a normal feature of orbital motion. By November of the same year, the rings will be visible again. By the year 2032, they will be on full display. But there is a bitter irony in this temporary disappearance. People will be concerned about an optical illusion and fail to notice the real tragedy that is happening every second. 45 tons of ice falling into the abyss, every second, without stopping, without the possibility of preventing it. The world watched Cassini from different points on the planet. Antennas in Australia, Spain, and California received its last signals. Scientists from the United States, Europe, and Russia analysed the data. It was not an American mission, nor a European mission. It was a human mission, and the discovery it brought belongs to all of humanity. We have learned that beauty is temporary, that even the most majestic structures in the universe have an expiry date. That space is not a frozen image, but a continuous process of creation and destruction. Saturn's rings were born out of catastrophe and will die, dissolving into the atmosphere of the planet they adorned for 100 million years. This is not a tragedy. This is physics, indifferent, relentless, beautiful in its inevitability. But for us, the observers, it is a reminder. 100 million years. What does that mean for a species that has existed for 300,000 years? For a civilization that has existed for 10,000 years at most? When Saturn's rings finally disappear, there will be no humans on Earth in their current form. Evolution, if we allow it to continue, will change us beyond recognition. Or we will change ourselves. Or we will cease to exist altogether. But there is hope in this. 100 million years is a long time. Long enough for a species that learned to split atoms and send probes to other planets in just a few millennia of development to become something we cannot even imagine today. A civilization that has gone from the first satellite to landing on a comet in 50 years could conquer the galaxy in 100 million years, or perish. The choice is ours. Saturn's rings are a clock, a giant cosmic clock counting down the time we have left. Not to save them, that's impossible, to save ourselves. We live in an era when we can see these rings. Our distant ancestors, if they survive, will not have this opportunity. We are witnesses to a fading beauty, and in this there is a privilege. In 1610, Galileo Galilei saw something strange on the sides of Saturn through his imperfect telescope. He described it as ears or handles. He did not understand what he was seeing. 45 years later, Christian Huygens saw the rings and understood their nature. Almost 400 years have passed since then, 400 years out of 100 million. We're observing the last 0.4% of this structure's existence, and we are the only known species in the universe capable of realizing this. Cassini burned up in Saturn's atmosphere so as not to contaminate Enceladus and Titan, moons where life may exist. We sacrificed the spacecraft for the sake of hypothetical microbes on distant moons. This says something about our species, about our ability to think beyond our own survival, about our ability to care for a future we will not see. If we preserve this ability, we have a chance. 100 million years. Saturn's rings will fall into its atmosphere during this time. First, the inner rings, C and D, will disappear. Then, more slowly, ring B, the densest and brightest, will disappear. Ring A will be the last to disappear. The process will be invisible to any observer, too slow for human perception, too fast for geology. And then Saturn will become just a yellow ball, a gas giant without a crown, just like Jupiter, just like perhaps all gas giants were, before random catastrophes gave them temporary adornments. We cannot stop this process. We cannot slow it down. We can only observe and draw conclusions. Space is not hostile, it is indifferent. There is no malice or cruelty in this indifference, only physics. Gravity pulls, magnetic fields guide, particles fall, structures collapse. This is neither good nor bad, it is reality. But we are part of this reality, capable of understanding it, capable of seeing patterns, capable of predicting the future millions of years ahead, and perhaps capable of influencing it one day. Saturn's rings are not eternal, the sun is not eternal, the earth is not eternal, nothing is eternal, but knowledge is passed on. From generation to generation, from civilization to civilization, if we build enough of them, from star to star if we learn to travel. Cassini died while transmitting data. The last thing this device did was send information, knowledge about how the world works, knowledge that the rings are dying, knowledge that time is limited. This is a legacy, not for Saturn, for us. The next time you look up at the night sky and see a yellow dot, remember, you're looking at a clock, a reminder that nothing lasts forever, and a challenge to become something great before the clock stops. Saturn is losing its rings. The question is what we will gain during the time they are falling.